With this video, we begin a series on limits at infinity. And limits at infinity are essentially, when they exist, are essentially horizontal asymptotes. So in this particular view here, we have 6 graphs and we have 6 functions or function definitions. And so we want to match the graph with the function definition using horizontal asymptotes. Now if we look at, we can either begin by analyzing the graphs or by the functions. One thing that I notice about these is that A, F, E all have horizontal asymptotes at 2, at y equals 2. So we need to find some way to distinguish among them. And if we start with looking at these, we go over to the function definitions. Well, the first one, because the degree of the leading term is squared, so the horizontal asymptote would be the ratio of the leading coefficients, 2 over 1, which is 2. So the first one definitely has a horizontal asymptote of 2. Let's see if there are any others. Number 4 also has a horizontal asymptote of 2 because x squared over x to the fourth, because the denominator, the degree of the denominator is higher than the degree of the numerator, so at infinity that's going to become 0, and 0 plus 2 will give you 2. Then finally 6 is also 2x squared over x squared, and so it will also have a horizontal asymptote of 2. So I need to find another way to distinguish among these, and I'm going to use the value at 0. So if I were to plug in 0 into equation 1 or to function 1, the numerator becomes 0, the denominator becomes 2, so that has a value of 0. So of the 3 that I just looked at, the only one that has a value of 0 when x is 0 is f. And that tells me that function 1 and graph f have to go together. For function number 4, when I plug in 0, I'm going to get, in the fractional part, I'm going to get 0 over 0 plus 1, which is 0 over 1, which is 0, plus 2 is 2. So when I look, I see that only graph A has a value of 2 when x is equal to 0, in addition to having a horizontal asymptote of y equals 2. So that means that function 4 has to match with graph A. Now with graph E and function 6, when I plug in 0 for x in function 6, I'm going to get 5 over 1, which is 5, and you can see in graph E that when x is equal to 0, y is equal to 5. So that means graph 6 is equal to E. And that takes care of 3 of them, so there are 3 others left. If we look at the graphs of B and D, we can see that they both have 0 horizontal asymptotes. And unfortunately, they also have a 0 value when x is equal to 0. So let's take a look at function 3 closer. X over x squared, the numerator has a smaller degree than the denominator, so therefore the horizontal asymptote, or the limit at infinity, will be 0. Now as you go to positive infinity, x is positive, x squared is always positive. But as you go to negative infinity, x will be negative and x squared again will always be positive. So as we go towards negative infinity, our values will approach 0, but they'll approach 0 from the negative side, whereas on the positive, at positive infinity, they will approach 0 from the positive side. And only graph D does this. Notice the values are negative, approaching 0 as x approaches negative infinity, and positive, approaching 0 as x approaches positive infinity. So graph 3 is D. So we have 2 graphs remaining. Function 5, as x goes to infinity, the denominator is going to get infinitely large, while sine oscillates between -1 and 1. So it will also have a 0, leaving 2 as C.